So I will be speaking today about development and testing Sophia smart contracts on Eternity. So again, an Eternity and more developer-focused topic. And for testing smart contracts on Eternity, we built a very small and simple tool that's called ÄProject, and it's working in collaboration with Devmode as the core team provides, and I will go through it. So first the question, what is ÄProject? Why do I need it? People write smart contracts, and of course in a smart contract you deploy logic that you in the future will not be able to change it if you have not built in a mechanism for change, as we heard earlier today, that this might be very complicated. So I probably want to test every case that happens or can happen and is supposed to happen in my smart contract and logic to make sure that it's working as I expect it to. And for this we built a small framework for people to be able to test their contracts quite easily, and also when they are not super familiar with Eternity yet. So yeah, as I said, what is ÄProject? ÄProject is a wrapper to do all this stuff for you and help you as much as it can while still being as unintrusive as it can. So we automated the setup of an Eternity node with a Devmode plugin and a local Eternity compiler that you can use and that you can also configure locally. It's just a normal Eternity node to most degrees. It includes an example project to showcase all the things and how to do testing, and yeah, just gives you a framework on how to get started testing, and then you can move from there. I think we've seen, for example, with the DEX smart contracts that they took this as a base and then they extended it very far for their specific needs when it goes to contracts that you work on for months or a longer period of time and evolve them constantly. And we try to stick to tools that were already there, not reinvent the wheel, just plug together what's already there. So if you're working with JavaScript, you're probably familiar with Mocha and Chai for testing, and we just plugged in those tools to do the testing for the smart contract. So there's very good existing communities, there's very good existing documentation, and probably every question that you have, if you use those tools, is answered on Stack Overflow, and it's not Eternity related at all. We just use it to test contracts, not JavaScript code. And we do this using the Eternity JavaScript or TypeScript SDK. So in the end, it plugs into there. And it also includes, as a last part of ÄProject, it includes some library functions. So functions that help you as a developer use some things more efficiently, like how do I control the dev mode? How do I work with the Eternity node? Just so we do it in very few lines of code. It's the least overhead possible for you to care about the logic of your smart contract. So yeah, for the library functions, it helps you to initialize a client. It helps you to initialize a new smart contract. It has all the dev mode interaction, and we have pre-generated some accounts for you to use. So you can, for example, if you test your access control management stuff, you can say account 1 is allowed to do something and another account, let's say account 2 should fail, right? It doesn't have the necessary access. And of course, ÄProject is fully open source, as all of the things we do at Eternity. And yeah, you can find a lot of documentation in the repository here when the presentation is eventually shared afterwards. And yeah, as I said, ÄProject is the framework around it, and one very important part of it is the dev mode. ÄProject worked before the dev mode, but it was slow because we had to use mining in the blockchain. There was no helper functions to deal with a chain, to stop it, to get the next block. It was just a normal local chain with dev mode, and yeah, thanks to the core team, especially Ulf there, it changed a lot, made our life a lot better. So what is dev mode? It's a plug-in to the Eternity core, as we've heard sometimes over the last days again already. And what it allows is the usage of the Eternity core node with a different consensus protocol. Basically, in the Eternity core node, the consensus is you have to mine blocks to be a proper blockchain, right? and have miners somewhere and proof of work and all of this stuff. In Devmode, we want to be the authority of what happens with our chain. So I want to say, please give me the next block, and it has to happen as soon as possible. So yeah, we have block generation control, as I said. The developer can decide when the next block should be generated. Key blocks on request. For micro blocks, it's possible to generate them automatically or on demand if you need them. You can have configurable intervals, so you can say, I want to test with a block every 3 seconds or every 10 seconds or every minute or so on. And what's really a big feature is snapshotting and rollback, so we can take a snapshot of the current blockchain state locally, take it, and then roll back to it in the future to say, I have set up, for example, all my base structure here, and I would want to jump back for the next test case, and this is possible in a few milliseconds, so I don't have to do the setup all over again. As some benchmarking numbers, we developed this together with the DEX team a lot to optimize it, because they had a test suite where they took a lot of the tests from Uniswap, and it was running for over 2 hours, as far as I know. And together with Devmode and a few other changes in Eternity, we brought it down to below 10 minutes, which is in the terms of average day workflow. It's like, I don't know, going out to the supermarket, doing grocery shopping and doing your laundry versus I'm just getting a coffee while my tests run. And I verify everything's still working. And Devmode is controllable via HTTP endpoints, or there's also a minimal UI for it that the core team provides, but in ÄProject you don't really see that. It's abstracted for you. And yeah, there's some default configuration that you do with your node config. And also here I just pointed out the open source repository and the sample configuration that we use in ÄProject, but this will be shared eventually. So I want to go a bit over how do we actually use ÄProject in our daily life, go into a bit of live coding and show you around. So also I think here, when there's a question, just raise your hand and I can show it instantly instead of doing it afterwards. So first, what we need to do is we need to install, we have to have npm and node installed. So it's recommended to have node version 14 and above, and you need to have Docker Compose. So I don't know if you're familiar, but Docker is putting computers into images and running them in containers locally on your machine without having to set up everything, and we use the Eternity node in one of those containers, so it's very easy to start and very easy to stop again. So yeah, those two are the requirements you have to have, and then you can install it as you may be used to from others. So this installs ÄProject globally for you as a command on your computer. And we can check that it's up and running for the latest version. Currently it's 4.20 or 4.21. And then what we do next is usually we initialize a new project, for example, our new test project. What this will do is it will generate a folder structure, set up some dependencies for you, and install everything. Takes a few seconds, also depending on your internet connection maybe, but it's as small as possible. And what this does, it sets up a few folders, for example, for some utility stuff that we need, like the Docker things, and a folder for contracts and tests. So for example, we have our example contract here. It's just a very small example that's shipped together with ÄProject to get you familiar with how the setup works, and some example tests to test this contract to show what's possible and how to deal with it. So you don't have to dive in the docs if you're familiar with testing and JavaScript. Next step that you would probably want to do is try out if everything works, so you can do ÄProject env to set up your local testing environment. So this will download the Aeternity core node together with a Devmode plugin. It will download the compiler to your local machine inside of Docker. So this may take a minute or two depending on your internet connection. For me, it's cached already, and I can see that everything's running using info, and I just see the output of Docker. As one of the goals for ÄProject was to make it as simple as possible, so we just wrap around the tools that are there, so maybe the output is not the most beautiful, but it's super simple, and you can basically do very few things wrong. And as everything is set up, we can just run our test suite, the one that's included, and you see within 1 second we deployed our contract. We had the method get and set there, so we set a variable and then we get it again, and we have a test for if we get something that it has not been set, it should throw an error, and of course this worked fine. So let's jump into how I would go ahead and develop my smart contract actually. So we can go into our contract and see our contract here. So we have our state where there's an integer set, just a counter or whatever we want to have it, and a set and a get method. What I want to do now, for example, is I just want some administrator or the creator of the contract to be able to set something and everybody else to get the value again. So I will put a require check for contract.creator equals call.caller. So it checks that only the creator of the contract can call this method. And if not, we receive this error message. This will be important a bit later. Let's save that. And let's run our tests again. Because now, in our tests, you haven't seen it prior, the setting happens with a different account than the one who created the contract. And now we expect it to fail. It says invocation failed because our check now works. And let's fix our tests now. So we can go into our test setup. There's, in the top you see before, we initialize our file system, we initialize the contract, we deploy an instance to our local blockchain, and we create a snapshot using Devmode. And after each test, we roll back to the initial state. And here in our set and test method, we first set something. Here we set number 42 using one of the default accounts that's provided, the account 1 that has been used also to deploy the contract. And now we set it to account 0, which is the one that has been used to deploy the contract. And this now fixes our problem that we had introduced, or our new logic, because it's now the same account. But of course, this doesn't check our condition. Does our condition, of course, still work? We want to check that as well. So let's code that in. So what I'm going to do now is I'm going to call my method using the other account. Basically, I'm doing what is done in the line above and catch the error so I can check it if this is the error I'm expecting. And let's do a different number, because here, for example, in the top, we check, we set number 42, and afterwards it should still be number 42. And of course, when our execution fails, we expect the new number not to have been set. And we define our on account to be our second or some other account. Doesn't matter what, actually. And let's use the account 1. And what we want to do here is we want to catch our error so we can check it later. And I just get the error message. And then we can do an assertion. Stupid stuff. we can assert that our error message includes the one that we expect it to, so is, what do we call it, set set only, let me check my docs, set only creator can set probably. Let's check it if it works. Live coding always is fun, right? Oh, it works. I didn't mistype anything. And now our new condition is checked for, and we can be quite happy and be somewhat assured that it works. Of course, there's always more things to check for if you want to be really sure, but that's one way to do it manually. The next thing that I wanted to show a bit is how we can now interact with or deploy our smart contract to mainnet using the aeternity CLI and how we can interact with that. And from time, we also have some time left, so let's jump into that. So we now have tested our smart contract, we're sure it works, and we want to deploy it to Eternity testnet or mainnet. So first thing we want to do is install the Eternity CLI. Again, this just uses npm. For the CLI. And we can see the CLI working. And let's create a new account here. We have to enter a password because per default the account that you store locally on your disk is encrypted. I'm choosing very secure password here. And then it gives me my newly generated public key. I can go to the faucet because this is generated on testnet now. I can top up that account and receive some testnet funds to play around with. And I can check the balance. Have to take the password to decrypt to have access to my wallet. And I can see 5 eternity with all of the decimals. So it's 18 decimals for the smallest unit of eternity. Let's go next to deployment. I have to check my notes. I'm very sorry for that. I have not done that in some time. So we can do a CLI contract deploy using our account. And then we just point to our contract source. So here it's in contracts example contract. Let's again type our password. And this will now interact with the chain, do a transaction, a contract create transaction, and we see our contract address here deployed. So now what we want to do next is we want to call our contract. So we can call it, we specify our account, our contract source again, and our address that we just copy pasted from here. And we can call our set method and we pass the arguments. For example, we want to set the number 1, again for access to our wallet, our password. And we wait for the transaction to execute on Eternity testnet and with the compiler. And we see something didn't work for some reason. Maybe I mistyped. Let me check. Maybe it's fine. Yeah, I think it's fine actually. And now we can get our number. I just was confused by the return value being false, but there is no return value given from setting it. And when we call our contract here, we can see our return value is 1, the number that we just set using our set method. Yeah, and that's basically how to interact with your contract on-chain. And I wanted to give also a very quick future outlook of what we want to do with these tools. So one big thing that we have to do still is Apple Silicon support for ÄProject. The Eternity node works on Apple Silicon without problems, but bundling it into the Docker image and Docker container is a bit more complex, sadly. So we're still working on that. For local interaction and exploration of your chain and changes that you did and the nice UI for it, we want to integrate the Explorer, so integrate another tool that we have, but it's still on the roadmap. And last but not least, we want to keep it as simple as possible. So for us, it's easy to maintain. For anybody else, it's easy to get into when you know the tools that we use already, because they're widely used and accepted. Yeah, that's it from my side. Are there any questions?
Okay. Thank you, Philipp. So.